little bit today about a new strategy for multiplication, which is called partitioned rectangles. And before we start talking about partitioned rectangles, there are a couple vocabulary terms that are really important for us to understand in order to do this process successfully. So the first word for us is the word partition. And if you look at this word, you see the word part in it, okay? And that gives us a big clue to what this word means in mathematical terms, which is to divide something into parts, okay? Divide something into parts. So if you think about the title of this video, Partitioned Rectangles, we're going to be dividing rectangles into parts to help us with our multiplication. The second word that we need to know is the term decompose. We're going to decompose some numbers to help us with this. And decompose means to break a number into smaller parts. Okay? Into smaller parts. So what does that mean? Well, let's take a look at a number and let's see if we can work out what it means to decompose a number. So imagine that we had the number, get it orange, well, I'll keep it green actually. Let's imagine that we had the number 84. And we know, because we know about place value, that the number 8 in 84 is in the tens place. Okay, so we know that that 8 is really 8 tens, which is 80. And we know that this 4, well, that 4 is in the ones place. So that's really 4 ones, which we know is just 4. So if we were to look at this number, 84, we could decompose this number into smaller parts. We could say 84 is really just 80 plus 4. Okay, that's one way to do it. You can also decompose into more parts. Okay, let me show you how you would do that. So if we took our number 84 again, so we have 84, we could also say that 84 is 20 plus 20 plus 20 plus 20 plus 4. 20 plus 20 is 40, 40 plus 20 is 60, 60 plus 20 is 80, 80 plus 4 is 4. You're just breaking down a number into the smaller parts that make up that number. So let's use that knowledge to help us with some multiplication that we might find a little bit challenging, or some multiplication that we might find new. So let's imagine we have a problem, okay? And the problem says, find the product of 65 times 4. Well, we're going to think about decomposing. And we're going to decompose this number right here, because that's the 2-digit number. We want to decompose the 2-digit numbers to help us get some easier numbers to work with. So I'm going to write 65, and I'm going to think to myself, well, what is 65 really? Well, 65 is just 60 plus 5. Okay, that's all it is. Okay, 60 plus 5. So now we're going to get to our partitioned part, our partitioned rectangles part. Well, how does knowing this, how does that help us with multiplication? And I'll show you how. And how does knowing a partitioned rectangle help us with multiplication? So we're going to draw ourselves a rectangle. Okay, it doesn't have to be perfect. It's not about perfection right now with the shape. It's just about getting the general shape. So there's our rectangle. And we're going to partition this. Remember, we said partition is to divide something into parts. Okay? So I'm going to divide this rectangle right here. And the reason why I did it right there is because you'll see right here we have two numbers and one of them is bigger. So I wanted to keep this consistent, okay? So I can visually see that 60 is bigger than 5. So the way I'm going to set this up is I'm going to take my 60, okay? And I'm going to put my 60 right here. I'm going to put my 60 right there. And I'm going to come and I'm going to take my 5. Okay, I'm going to take my 5 and I'm going to put my 5 right here. And you can really think about this, even though it says 60 and 5, we can kind of put a little parentheses addition. We're really thinking 60 plus 5, okay? Because if we think about this whole space, right? This whole space is 65. Well, we can't forget though, what are we multiplying by? We're multiplying by the number 4, okay? So we're going to put that 4 right here. And now we have our partitioned rectangle set up. Okay, now we can do the multiplication to help us. So here's what we do. We take our 4 and we multiply it by 60. And this should look really familiar. This is an extended fact, right? Our original fact was 4 times 6. If we made an extended fact, we would now do 4 times 60. We can do those. Well, what is 4 times 60? 4 times 6 is 24. How many zeros? We have 1 0, so let's add our 0 right there. 4 times 60 is 240. Now, let's come across and let's do 4 times 5. Well, what is 4 times 5? That's 20. So now, we have our partition rectangle filled with the numbers. We have a 240 here, and we have a 20 here. All we have to do now is add those two sums together, or those two products, excuse me. We have 240 plus 20. That's going to give us 260. So 65 times 4 is 260. Let's do another one, okay? These take practice. Let's do another one. I'm going to erase all this. We'll keep our box the same. Let's keep that because we're going to use it again. Keep our rectangle the same. And let's say for this one, let's find the product of 74 times 41. Okay, 74 times 41, and you're going to notice something here. You're going to say, wait a second, this looks different. Both of the multiplication problems have 2 digits. Well, guess what? It's the same thing. We're going to divide it right down the middle again. But now we also have to divide it this way. Okay? And let's decompose our numbers. 74 is really just 70 plus 4. So I'm going to put right here 70 and 4. 41 is really just 40 and 1. Okay, so I'm going to put 40 here and I'm going to put 1 here. And now I'm just going to do the same thing. Okay? 4 times 7 is 28. How many zeros? 2. 40 times 4. Well, 4 times 4 is 16. How many zeros? 1. 1 times 70 is 70. 1 times 4 is 4. Now, we simply add all of these numbers up. So, 2,800 plus 160 plus 70 plus 4. Okay, well, in the ones column, we have a 4. In the tens column, we have a 13, and let's carry the 1. In the hundreds, we have a 10. Let's carry the 1. 2 plus 1 in the thousands is 3. Okay, the product of 74 times 41, 74 times 41 is equal to 3,000 34. Okay. Let's do one last one just to double check. Let's go back to a 2-digit by a 1-digit. Let's go back to that. We will do let's do 28 times 8. 28 times 8. No problem. We're going to draw our partitioned rectangle. Okay? No problem. We can do this. We're going to partition it. We know 28 is really just 20 plus 8. So I'm going to write 20. And then I'm going to write 8. And we know that 8, well, that's just an 8. Okay? Well, what is 8 times 20? Well, I know 8 times 2 is 16 and 1 0, so 160. I know 8 times 8 is 64. And now I just add them. 160 plus 64. 4 plus 0 is 4. 6 plus 6 is 12. Carry the 1. 1 plus 1 is 2. 28 times 8 is 224. That is how you used partitioned rectangles to help you with your multiplication. See you in the next video.